In a certain experiment, a sample of helium in a vacuum system was compressed at 25 degrees C from a volume of 200 milliliters to a volume of 0.240 milliliters, where its pressure was found to be 30.0 millimeters of mercury. What was the original pressure of the helium? Well, what isn't changing here is apparently the temperature, because it talks about compressing the gas at 25 degrees C, and they don't mention a different temperature, so we'll assume this is a constant temperature problem, which, if we look at our note card of equations, the one for constant temperature is Boyle's law. Temperature is constant. So we need to use P1V1 equals P2V2. So let's go ahead and write that out. And they're asking for the original pressure of the helium, so they're asking for P1. In order to use this equation, we need to isolate P1 on one side and have all the other variables on the other side. So let's use algebra and do that right now. Now we have P1 isolated on the left side and all the other variables on the right-hand side. Now we can proceed to plug in values for the right-hand side. Pressure 2 is 30 millimeters of mercury. V2 is 0.240 milliliters. We have to divide this by the initial volume. Initial volume, 200 milliliters. Now that we've written out the equation with the values substituted in, it's a good idea to look at the units. Will they cancel properly? Well, milliliters will cancel with milliliters, and the remaining units are millimeters of mercury, which is good because you're looking for a pressure. So let's get a calculator and do this calculation. 30.0 times 0.240 divided by 200, we get 0.036 millimeters of mercury.